Hello, in this video I'm going to solve the following problem for you. This is a problem on the topic of rational equations. Determine all real solutions of the following equation. 1 over x minus 1 times x plus 1 over x times x plus 1, and the pattern continues until 1 over x plus 9 times x plus 10 equals to 11 over 12. That would be a good idea if you pause the video at this point and give it a try yourself. If you do the calculations correctly, the answer that you get for this problem are two actually solutions. One of them is x equals to 2, and the other one x equals to minus 11. If you are interested in this type of problems, you are referred to the following playlists. The link to the PDF file that you see on the display now is in the description below this video. Okay, so let us solve this problem. So this is a problem on the topic of rational equations. As you know, the standard way of solving that is finding the LCD of all denominators of all fractions on both sides and multiply the left and the right by that LCD. This will help us to get rid of all fractions, and in principle, solving an equation without any fractions should be simpler than solving an equation with fractions. But of course not for this case. So if the problem becomes a little bit higher level problem, you need to train your brain to see how you can think outside the ordinary box here. Okay, so if I want to find the LCD of the denominator, so in principle, because there is no common factor between these, so the LCD is the product of all the factors that you can see here. And if I want to multiply the left and right by that, so good luck with that, yes? There is no way that we can actually, of course there is a way, but it's extremely tedious if you want to do it in that way. So what is the key observation here? The key observation is that to see that more or less, even though the terms involved are different, but the same kind of pattern reveals itself in all the denominators. So I have x minus 1 and x, they differ by 1 unit. I have x and x plus 1, they again differ by 1 unit. The same story here, x plus 1, x plus 2 differ by 1 unit, and the same is true here. So might be there is a reason that the person who designed the question in that way. Okay, so for example, let me do it like this. Might be it is not that evident why I am doing what I'm going to do now, but the whole point is that these kind of problems are famous. This is somehow the notion of what we will see is called a telescopic sum. Okay, because I have already trained myself on this topic, so I can immediately recognize the pattern. And the whole point of these problems is this. So you see some problems, you learn the point, remember it, and hopefully you can use it for similar problems. Okay, so what I will do, instead of 1, I can write x minus 1. And then I repeat the denominator, x minus 1 times x. First of all, I want you to understand that this is correct, because if I multiply the minus sign in x and x are gone, minus minus becomes 1, and that's correct, and the denominator I had just copied and pasted that, so that's correct. But now I can decompose this one single fraction to the difference of two fractions. How? I can write x over x minus 1 times x minus x minus 1 over x minus 1 times x. Yes? Okay, and it is simple to see why. For example, let us say that I have given you these two fractions and I have asked you to combine them. Because you see the denominators are the same, you put the same denominator and then you subtract the numerators, which becomes this. But what is the benefit of that? This x and that x are factors, common factors, they are gone. This x minus 1 and that x minus 1 are gone, so I am left with 1 in this numerator and x minus 1 in the first denominator. And in the second one, again, I get 1 in the numerator, but I get only x in the denominator. So what I have done, I was able to write this one single fraction as the difference of two fractions. But look, x minus 1, the denominator of the first one, is the first factor, and x, the denominator of the second fraction, is the second factor. And I hope that you understand that this pattern can continue. For example, let us do one more. Here, 1 over x plus x times x plus 1. This 1 can be viewed as the difference between these two terms. X plus 1 first minus x. That's exactly 1 again. And then I would copy and paste the denominator. I will follow the same pattern. So I decompose this one single fraction into the difference of two fractions minus x over x plus 1. And now what happens this time? X plus 1 and x plus 1 are cancelled. Here x and x are cancelled. So I am left with 1 over x minus 1 over x plus 1. So you see the pattern is repeating itself. I have one fraction, and now I have decomposed this into the difference of two fractions. The denominator of the first one is the first term, is the first factor, and the denominator of the second one is the second factor. And I hope that you understand that this can continue. I don't want to do it for the next one, but I hope that you can guess what is going to happen, okay? So this can be immediately done in that way, but what is the benefit of that? You can write it as 1 over x plus 1 minus 1 over x plus 2. It is not hard to convince yourself that this can continue. So I again wrote this as the difference of two fractions. The denominator of the first one is the first factor. The denominator of the second one is the second factor. But do you know why this is useful? Because I am going to add these fractions. So instead of adding these fractions, I can add their equal ones, yes? Because this one is equal to that, this one is equal to this, and this one is equal to that. So instead of adding them, I can add these two. But what is the benefit of adding these ones? Because this one canceled that one, and this one canceled that one. Like, I mean, have you seen this telescope when you open it up? So it becomes like, I mean, something that you can see stars, but then you can compress it and it will be very small so that you can actually carry it with you. I don't remember the English names, but yeah, so probably you have seen them in the movies or something like that. They open and then see with one eyes and then compress it back, yes? You can carry it easily. But that's what I'm saying. So this pattern can continue until you reach at the very end. So this becomes 1 over x plus 9 times x plus 10, and then hopefully you understand that this will continue and it becomes 1 over x plus 9 minus 1 over x plus 10. Okay, so now the left-hand side is the sum of these. To understand what the left-hand side is, I need to add them, but instead of adding them, I can equivalently add these. But when I add them, this one and that one are gone. This is negative, this is positive. This one and that one are gone. And then if I continue, this one with the next one will be gone. And there is something here that will cancel this one. So there are only two terms left. This one is left from the very first term, and this one is left from the very last term. So if I combine them, everything will be cancelled out except these two terms. So this becomes 1 over x minus 1, and then I have minus 1 over x plus 10, and that is equal to 11 over 12. But that is a very simple rational equation. Then I can go back and think in the box. I can find the LCD between all fractions, which is of course 12 times x minus 1 times x plus 10. And this LCD, I multiplied here, here, and there. If I multiply it here, x minus 1 and x minus 1 are cancelled. I am left with 12x plus 10. If I multiply my LCD here, x plus 10 and x plus 10 are cancelled, 12x minus 1 is left, that I will multiply it here, and then I have a minus sign. X minus 1, and on the right hand side when I multiply here, 12 and 12 are cancelled, 11 survives, and then I have to multiply this with 1 as well. And that is an extremely simple problem to solve. Yes, so what I do, I open it up. So I multiply 12x plus 120. I multiply minus 12, minus 12x plus 12. And then here, I multiply these two, so it becomes x squared. 10x minus x is 9x, and then minus 10. But I have to multiply 11 inside, so it becomes 11x squared plus 99x minus 110. Okay, so this 12x and that 12x are gone, so I have 11x squared. I have 99x Yes? And what else? I move a 120 to the other side, it becomes minus 120, and that minus 110 is minus 230, minus 12, minus 242, equals to 0. Yes? Then I want to solve this equation. For example, I can use ABC formula, or I can use PQ formula. Might be PQ formula is not a bad idea here. If I want to use PQ formula, I divide everything by 11. So this becomes 9x, and this becomes minus 242 divided by 11. But 242 is also divisible by 11, yes? How many times? 22 times. Yes, so that's also 22 times equals to 0. Okay? I can use again PQ ABC formula, but I can also factorize it. Factorization is not that hard. So I put 1x here, 1x there. I ask myself, what are the numbers whose sum is positive 9 and the product is minus 22? So it is positive 11 and negative 2. Yes, do you agree? Yes, because if I add them up, it becomes positive 9. When I multiply them, it becomes minus 22. This is supposed to be 0. The product of two numbers is 0. Either the first one is 0 or the second one is 0. If the first one is 0, it means the answer is minus 11. If the second one is 0, it means the answer is 2. But one more thing that I have to be careful when it comes to rational equations is that might be some of these roots, or one of them, or both of them, are false roots. But none of them is a false root, yes? Because if I put x equals to 2, none of them vanish, and this one is also 1 times 2, so that's okay. So 2 is acceptable. And if I put minus 11, again, none of them will vanish, yes? So it means both numbers are acceptable. So this means that this equation has exactly 2 solutions. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.